February 2021, the Mars Perseverance rover touched down delicately on the surface of Mars with a primary mission to collect rock and soil samples that will eventually be transported back to Earth. Did you know that only 40% of Mars missions are successful? One of the reasons for that is that Mars is really far away, as in 140 million miles away. For perspective, if you were taking a space road trip, with 3 of your best friends traveling to Mars at 70 miles per hour, the road trip is going to take 230 years. So for the 2020 Mars Perseverance rover to make it from Earth to Mars in a, reasonable amount of time, 7 months, the spacecraft flew at roughly 12,000 miles per hour. Entry, descent, and landing, EDL, refers to the critical phase of a mission during which a spacecraft transitions from traveling at breakneck speeds to landing delicately on another planet. Now, Perseverance boasts some truly remarkable engineering. However, let's hit the brakes for a moment to explore how EDL innovations are revolutionizing emergency response efforts here on Earth. I'm Lindsay Tober, and this is Space for Humans. So how do we stop a 12,000 mile per hour object in space? To learn how Perseverance rover did this, here's Dr. Eric Stribling.
Now, the Perseverance rover reduced speed using an extremely sophisticated and expensive combination of high-temperature shielding for friction, a parachute, and eventually a self-destructing helicopter, all of which allowed the spacecraft to touch down at less than 2 miles per hour. But what if we could find a simpler, cheaper way to survey the surface without a dramatic helicopter crash? Though it was pretty cool in Die Hard.
Mechanical engineer Dr. Alice Agagino received a grant from NASA to explore a new method for capturing data in extreme extraterrestrial environments, with a much simpler method for EDL. Based on the science of tense gritty, think about how a bicycle wheel distributes weight evenly. She co-founded a company called Squishy Robots Incorporated that came out of NASA's early stage innovations program. Dr. Agagino's original goal was to create robots that could be deployed to the Moon and Mars to inexpensively collect data. But then she realized that these harsh, extreme environmental conditions her team were designing for also exist right here on Earth. Squishy Robots Incorporated has created a robot that can enter dangerous zones here on Earth and report data back for emergency response teams. These robots are light and malleable, making them easy to transport and attach to drones. These robots can go into disaster zones and evaluate if it's safe for first responders to enter. In the military, these robots can monitor gas and electric lines and even defuse bombs. This project, originally created for space, is saving precious lives here on Earth. Squishy Robots Incorporated has the potential to revolutionize not only emergency response, but also military operations and hazardous industries. Due to the ability to handle extreme environments, these robots are ready to tackle anything that comes to them.
So if one day your company's annual office Christmas party escalates into a high-octane cat-and-mouse game with master criminals, culminating in a satisfying yet gratuitous array of explosions, and a helicopter crashing into the Nakatomi Plaza, adorable little robots might be deployed to your side to assess whether it's safe for a rescue operation to proceed. And if this day comes, you'll have NASA to thank for saving your life. Well, maybe. At least the lives of the emergency responders.
Anyways, and before you embark on a 140 million mile road trip, think about sending out some squishy robots to scout the terrain for any dangers. Thank you so much for watching. Please like, share, and subscribe, and hit that notification bell for more Space for Humans.
I'm Lindsay Tober, and this is Space for Humans. To tell us more, Eric! All right, just getting warmed up.